Hello and welcome to Dedicated Cloud, an introduction to Equinix Metal. Today's webinar is sponsored by Equinix and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech, and I'm delighted to be your moderator for this special event. Now, before we get to today's great session, we have 4 housekeeping items that are going to help you get the most out of it. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. So not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you have. The Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh will fix most audio, video, or slide advancement issues, but if that doesn't work, just let us know in the Q&A and we'll provide further technical assistance. Now, second, in the handout section of your webinar control panel, you'll find that we're offering several resources. I'd especially like to call your attention to a lot of links in there. The first one is to the Equinix main site and information about getting started. There's also a link to documentation about Equinix Metal. And the other links are to things that you're going to hear about in this fun presentation that's coming up that you can click back to for more information, like the Traceroute podcast, an XKCD comic, a Netflix blog post, and a Forest Brazil blog. So check those out. I encourage you to access those resources now and share them with your friends and colleagues. Now, third, at the end of this webinar event, we'll be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of today's prize drawing can also be found in your handout section. Just scroll to the bottom and you'll find the link with the details there. Now, finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenter. So to help encourage those questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. So after the event is over, the Actual Tech Media team will look through all the questions that came in, pick out the very best one, and contact that prize winner. All right. So with that housekeeping out of the way, let's get to today's fantastic session. So it's my pleasure to introduce you to our presenter today. We have Fen Aldrich, who's DevOps advocate for Equinix. Fen, welcome.
Hey, thanks for having me. Glad I
Thanks
could
for
be
being
here
here.
and present this to you today.
Super. Well, I'll turn things over to you, and I'm looking forward to this presentation.
Sounds great. Cool. So we're going to talk dedicated cloud. It's kind of I think it's a relatively newer term compared to certainly all the other cloud terms we have. So we're going to explore a few different things about that. And I was going to start my agenda, but that's a slide later. So we'll do it in order. So I think what I've been seeing in trends as I've talked to other folks in the industry, it seems that the hybrid infrastructure is kind of inevitable. And really the key to all of this and making our cloud experience work for us is figuring out how to tie that all together and actually integrate all of our experiences across the board. So that's what we're going to dive into today. I'm Fen Aldrich. I generally use they or she pronouns. I've been a DevOps advocate for a while now. I've worked a number of places. I did a bunch of the DevOps Days events. I've organized them in Connecticut and New York and Boston, and have been a part of that since like 2016 or 17. Podcast, as you mentioned, I'm on the Traceroute podcast. I've done a few others. If you ever check out the Greater Than Code podcast, another one I'm particularly fond of, but I don't think it runs new episodes anymore. I like complex systems and human factors and, networking stuff, making sand talk to other sand, for better or worse in our environment. I don't know if our first mistake was tricking sand into accounting for us, maybe our second one was getting it to talk to each other. But, so let's talk about, sand communicating today. So that we had an introduction. I'm going to dive into some brief context of kind of what's the state of cloud right now. How did we get here? What is dedicated cloud? How does that come in as a different entity? We'll talk specifically about Equinix and Equinix Metal and how that particular platform approaches dedicated cloud and what it looks like. I'm going to do a demo. So we'll actually dive into the Equinix Metal platform, see what it's capable of, and kind of finish up with sort of tying bits of it together in sort of a demonstration there. And then we'll finish up with the Q&A for any questions. I'm happy to like jump back and dive deeper into stuff either in the platform or in the questions. But yeah, let's get started and see where it goes. So how'd we get here? So this is like what I remember as the first professional server rooms, right, that I worked on. And I'm sure a ton of people have experienced this. Like maybe you just started somewhere, you walked into a network closet and like, you know, maybe did the Abe Simpson, like walk in, hang your hat, walk back out again. But it all started with like, you know, boxes and closets that we had here. And eventually we graduated to data centers and co-locations and all these big chilled rooms full of computers. We kind of got to the someone else's computer stage of cloud. I definitely remember early cloud and that really being kind of what we thought of, right? You weren't using a computer in your data center. You were using compute in someone else's data center. And that kind of left all of our snark behind, right? As it actually grew into the giants and hyperscalers that we see now that are not just doing compute, but offering additional services on top of that, functions as a serverless, functions as a service, I mean, and, you know, all these other services that you can consume on demand. You can spin it up, you can bring it down. And it just exists out there in the nebulous connection that we call the cloud these days. And in fact, a lot of folks have gone through this change as well, right? And Netflix posted in 2016 that they completed their cloud migration. They're out of data centers and fully in the cloud as of 2016. What I find kind of funny is I think they mentioned in this blog that they started in 2008, and now we're 8 years hence from there. So I wonder what the reflections are now, it being as long as it took them to migrate after they finished that migration. But I don't know. So yeah, so a lot of folks embraced that cloud, right, as a way to move fast, as a way to have a more robust or dynamic architecture or infrastructure without having to build all of these data centers and maintain their own chillers and their own power and their own multiple ISPs with multiple routes to the data. Like that's all additional overhead they had to maintain. But we're also seeing this other trend, right? So we've seen from DHH, creator of Ruby on Rails, who, you know, I'm not necessarily fond of personally and think what you want one way or another, but still an interesting person in tech, right? And they have interesting opinions. And he says they're going to save $7 million over 5 years exiting from the cloud as of 2023. So like $1.5 million a year. So that's very interesting, right? Like we're 7 years later, almost exactly in this case, and seeing an exact opposite trend moving out of the cloud. Now, I don't think this is as much of a pendulum swing, and this is where the Forrest Brazil blog post came in, right? Who sort of agrees with me on this and drew this little, you know, quadrant diagram about where you're probably going to be expanding to and where you're probably building. Like all diagrams that divide things into quadrants and anything that's very hard transitions between sections, I think the truth is probably somewhere in the middle and a lot in the gray areas. We're probably seeing a lot more folks, especially in enterprise, having some of their compute, maybe legacy compute, maybe mainframe still living in data centers on-prem or in colo, while also embracing cloud services and virtual cloud and everything else, right? So there's some hybrid cloud, probably using multi-cloud. I've talked to startup providers who end up building on one cloud, you know, from the get-go, right? They're planning on staying with this. But as they mature and find out they want to offer their product to another cloud provider in their marketplace, that marketplace requires them to use some of those cloud services. So now they're expanding into multi-cloud out of necessity to get their product out the door. So this is just kind of the way things are going. People are consuming services from Amazon and Google and Azure and on-prem. So where does dedicated cloud fit in? Like, how does this fit into that picture, and what's my interpretation of that? Sorry, got dry. So if on-prem gives us kind of the extreme end of control, right? Like, as I mentioned before, you have to maintain all of these different infrastructure items beyond just, the compute cost, but you have to maintain the actual physical infrastructure, the cooling, the power, and the people to rack and stack servers. And you have to develop some way to load those into inventory and track these assets. But it lets you do everything you want. You can pick the brand of processor that you have, if that matters to the application stack that you're building. You can pick the brand of network cable and how many twists are in it, right? Like, you have complete control of your infrastructure here, but it costs a lot of time and effort to maintain it. And cloud gives us the extreme other end, right? You're doing mostly virtual machines or services. You don't get access to underlying hardware layer. You can't do much about the network that you're on except consume it or don't. Have backup plans for when things fail. You don't get low-level network access. You're kind of stuck in these virtualized environments. But you get a lot of flexibility, right? You can bring things up and down whenever you want, and you don't have to maintain all that backend infrastructure. So dedicated cloud is kind of somewhere in between these two. If I was drawing a Venn diagram, this would be right in the middle. This is giving us cloud-like access where you can have a console and spin up a machine, but it's an actual physical box. It's bare metal, right? And you can access it programmatically, and you can have control to install your own OS. You don't have to use one of the prepackaged OSs we have. You can have your own custom iPixie images, or you can change what layer network your NICs are operating on. Maybe you don't want them connected to the internet. So you have all that level of control without giving up the convenience of being able to spin things up and down on demand. So that's where Equinix Metal fits in, right? That's kind of the place that Equinix Metal operates. So yeah, surprise, surprise. This was a picture of our interface and code that I've used to actually access Equinix Metal devices. And it's not just this, right? If this were the only thing that Equinix Metal was, it would be kind of interesting, but there's other bare metal offerings out there, right? You can get these kind of services if you're willing to play the right games and pay the right money to the right people. But we've got the ability to interact on all these different terms. Like, as you would expect from cloud, we have console access. There's a pure API. If you want to write your own software against it, you can integrate through the command line interface, through Terraform or Infracode. And we're going to integrate just like cloud would with things like cloud providers, right? With whatever infracode provider you want to do. The idea is that Equinix can support that and interact the same way you're already building your infrastructure in the cloud. So if you're doing GitOps and you're doing best practice of documenting your code, documenting your infrastructure via code and committing it to Git and doing all that sort of thing, we want to maintain that. That's a good practice, right? We want to maintain that for you. So we can carry that over to bare metal, and you can auto scale in Kubernetes, but you're doing it with bare metal servers, and you didn't have to build an interface on your back end to inventory and check all of your servers and make sure there's enough and spin them up and down automatically. We can handle all that. And again, it's not standalone. Equinix, as you may have heard before, like before you hear Equinix Metal, you may hear things like our IBX or our colo facilities, and maybe you've heard of Equinix Fabric before. This is kind of the magic of where I think it's really interesting, right? Why do I work here and work on this thing instead of something else? Because this Fabric connection is really the interconnection between all of it and ties everything together. We actually have a service I'll show you in a little bit in the demo called Interconnections inside of Equinix Metal, right? So this allows us to build a private network connection through our Fabric service to a cloud provider or to your colocation in one of our IBXs or somewhere else. Maybe you have an on-prem that you need a connection to. We can negotiate those things too. This is all stuff you'd normally have to work out on your own with the colo facility. Make sure the provider can make those connections, find the neutral connecting point. We've already done that. So sometimes you might find, because of locations, really, really convenient connections that are extremely fast and don't traverse the public internet ever. As an example, here's all that. I'm clicking the slide instead of the next button. There we go. Here's all the locations we have Equinix Metal, right? This is a place where you can, right now, if you wanted to, sign up, get started, create an account, and bring up a bare metal server in any one of these cities marked on the map. And then it'll be there in that location, nearest wherever your customers are, or wherever you need to hold your data. Maybe you have data that's really important. It stays in Europe because it's under GDPR. And if it leaves Europe, you'll be fined a lot of money. And what's interesting about these facilities is they, go figure, correspond to the regular Equinix data centers, right? The IBXs that are there. And those are situated next to 41% of all hyperscale on-ramps. So all of the ways that hyperscalers get to the internet, 41% of them are through Equinix facilities near Equinix Metal. So coming briefly back to that diagram, I should have put it twice. You might, for instance, have your actual managed boxes and infrastructure that you have in a colo cage at Equinix, and you might have Equinix Metal, and you might interconnect all of those through to your cloud services, AWS and Azure, and all of those services might be talking within the same data center facility. So you're talking not only very completely private network connections, but potentially extremely fast internet connections as well, right? Like, it doesn't have to go out to the internet and come back and go out to the internet and come back and add all of these layers of security and protection and, all of this network overhead traversing, through gateways over and over again. Low latency and secure. So what more can you ask for, right? So I want to dive into the actual platform. This is where we can kind of mosey around and take our time and see what it actually looks like in practice and what we can do with that sort of thing. So let me move things to the right window so I don't do the 1000 infinite screens thing. Screen 1, there we go.
Okay, I see it.
Cool, awesome. So you should be up and see the server list that I have here. This is kind of my test server. I baked one earlier, because it's always good practice when you are tempting the demo gods. But this is what it can look like. You set up a project, and it's just kind of what you'd expect from any console. You can bring up a new server, deploy on demand. We can put it in whatever metro we want to. I think that one's in Dallas, so let's do another one there just for good measure. These are all different server types that are available in those metros. You can see that as you switch, maybe you need something in Europe, in Milan. You have just different server types that are available. You can find all those out. There's a capacity planning site that's in our documentation, or you can check those sorts of things through the command line as well. But yeah, so let's set up in Dallas because we know that one's up and has what we want. All these different server types. This is kind of general medium volume compute. You can do everything from specifying, storage or network optimized. This is one of the few network optimized. You'll see it has 4 by 25 gig network ports available to you. So that's literally 100 gigabits per second that will be bonded between you and a backbone to the internet. So if you absolutely need to optimize your network connection and, don't want to worry about noisy neighbors, we've got you covered with that stuff too. That's kind of the fun thing about building servers where all the hyperscalers converge. We'll do Ubuntu. It's pretty quick. If we've got an image ready, it'll deploy almost instantly for us. Let's call this number 1. Let's zero index properly. And we can just deploy, and just like that, server request submitted. And we can see it's queued up and it'll start deploying for us. So it won't take too long, but it's going to take a little while to go through. So I can show us what we've got in the meantime. Already going. So you can check the status if you want to. You can wait for things to come back. There's lots of different things you can do to run checks to do that more automatically. But once it's up, you can connect just like you would to any server, right? We just SSH'd right into the 00 server that I set up earlier. Now there is some configuration. If we dive in to the server itself, you'll see it's been populated with all the SSH keys from the project. This is a shared project. So you'll see we've kind of got everyone who works on stuff here. But yeah, you can control that too. When you deploy a server, you can pick fewer or add in additional SSH keys as long as your account has access to them to deploy. So yeah, and then it's just, it's just like anything else. So I want to see this other server come up here. What do we got going on? It'll be another minute or so. So I've already kind of pre-configured this one. If I do IP address, I've done some interesting things here, and I've added this private network connection already. This isn't something it came with. It came with this bonded network connection. Let's look at the network settings here. So it's using a bonded network connection, and it's hybrid is what I switched it to, which I have to disconnect it from all my stuff in order to change it. But that means I'm living on layer 2 and layer 3 of the IP address layers, the OSI layer model. So if I wanted to, I can connect on a private network that has its own broadcast domain. And I'll connect up the new server to it, and we'll see them. They can communicate there without ever communicating over the public internet to get out and back again. But it's still connected to my layer 3, and I don't have to worry about like those two different network cables or capacity. They're just going to run simultaneously, kind of the easiest way to hybridize your connection. So that's been set up on an internal network here. And there we go. Cool. So we've got the new one up. So we're going to log into that new server here. So we see we've got 01. And we can see the IP address only shows this bond 0. So first thing we want to do, let's go in here to the actual network settings. And we're going to convert that network type. So see, instead of hybrid, it's in layer 3 mode. It's only going out over an IP address. It doesn't have any VLANs or layer 2 networking connected to it. We're going to do this one easy. We're not going to get into the deeply advanced, like splitting it into layer 2 only, because that'll require like fancy backend connections. If we have time at the end in the Q&A, I can mess around with that stuff if people are interested. But for now, we're going to do a hybrid connection. We're going to connect it to that same VLAN. And we're going to keep it a bonded pair for the network ports. That bonded pair assures both, if you're not familiar with it, it assures both redundancy. If one of those disconnects or it has an issue with the cable, something physically goes wrong, because it is a physical box, it's not going to lose your connection. The other pair stays up and it treats it like a single network connection. And at the same time, it also doubles your bandwidth, right? It can send twice as much because it, again, treats it as a single network connection. Okay, cool. So we're up and on that VLAN. Let's see if I remember my commands correctly here. Oh. All right, let me look it up real quick. I knew I should not have relied on my memory for that one. That's one we should always write down. No, you're not going to tell me. I bet if I do the help, it'll show me. This is my hubris. Yeah, I'll definitely remember. I don't need to write that down. IP link add. Oh, add link device name. Okay. IP link add link. No. Add link bond 0 name bond 0.1000 type VLAN ID 1000. Hey, I knew we'd get it. So now we can see we added that VLAN here, because those for folks that are familiar with VLANing and all that, it's going to be a tagged VLAN over that port. So we needed to create a tagged interface for it to recognize. Now we'll see we don't have an IP address for it yet. Let me remember my commands one more time. IP address add IP, and I think 192.168.1.20. Let me make sure that's the right way to do it. Yep. Dev bond 0.1000. Even experts have to look up their commands again. And then we can go IP link. IP link set bond 0 up. Okay, so now we can see we've got that port is up. And if I correctly did my IP addresses, I should be able to ping 192.168.1.10. And there we go. So this is actually pinging back that first server I created before over a private network that doesn't touch the public internet. You can see it's what we're in the hundredths of milliseconds response time here. So very quick private connection, and I can communicate between these two servers now. If I wanted to, I could actually go in and build up a whole private network with its own gateway, just like you would if you were building a private network anywhere else, right? Your servers live in your network. You have a firewall or a gateway that's going to connect them out to the internet. I could do all of that if we wanted to get cheeky with it here. So what I want to do is I want to install Nginx on this one here. Because I've actually got it on the first server. If I come out here and copy this IP address and paste it in, I've got Nginx running. I've just replaced the homepage to tell me what the host name of the server is. So we can even, once this is done, if I wanted to, I can curl it and get the poorly formatted thing because I did it in a rush earlier today. But we want to deploy this ourselves. So let me just remember where that file is. All right, let me copy and paste my thing here. That's going to be indented wrong, but then we'll fix it. Oops. All right, that should be good. Awesome. So we should see if we take the second IP address now. Probably have to read that. Oh, because I didn't create the file the right way. It's fine. We can go in and edit that here. Sorry, I'm borrowing this from a file. The reason that it's not correct here is that I'm borrowing this from an automatic configuration file, which I'm going to show you in a second. So this one is what, DA01. Does it work automatically? Cool. So there we go. Cool. So I deployed those, and I deployed those using, in case it got cut off, this cloud config here. So I literally just dumped this YAML file into the user data field, setting up the server. And that's going to do, it's going to do an apt upgrade for us. It's going to install Nginx automatically, and it's going to create that index file automatically and then restart Nginx for us so that we know that's done. No, do not update in the middle of an. What are you thinking? Sorry. So that's what's being deployed to those three servers right now. And I'm going to go in while we're waiting. I was talking about load balancers. So I want to set up a load balancer for our little, now extremely highly architected and robust hello world that we have going on. We're going to name it very excitingly LBO1. We're going to have it redirect our port 80. A nice, very exciting pool one. And we're going to have it pull in some metal servers here. So we're going to pull in server 1 on port 80. And we can go ahead and just add all of those if we want to. Oops, I did that already. Number 1. Two. 3 four servers. 5, I guess. The count did not prepare me for zero indexing. So we're going to create that pool. That is created. That now shows up in our load balance report, and we're going to deploy it. So we're doing all this at once. We're not waiting for anything to deploy or waiting for anything to show up for us. We've got it created. We've got another public IP address here that's linking all of these servers. And we've got them all deployed right now. So it may take a minute or two for Nginx to fully set up on those. But let's see what we've got from this this thing here. We had O1. That one worked. Let's see if O2 is working. It's going to be fun if only some of them work. There we go. O2 is working. O3, awesome. We're just going to trust that O4 works because that way it's more exciting if it doesn't. And we're going to go back to our load balancer. Let's take this other IP address, 200.23. That's different than all of our others. And we can do exactly what you'd expect. We can put that in, and it's going to give us one of the servers. And that's the one answering fastest right now and is most excited to see me. You can go ahead and put this IP address in. If anyone wants to, try the exercise at home, 147.28.200.23. If you put that in your web browser, you should just get a website up that gives you a host name of one of the servers, whichever one happens to answer you. This could be caching too. I don't know if I'm caching the site as well. There it goes. So you see, whichever server happens to come up, it's going to switch between them. And if I, for instance, take that server offline, if something happens and let's see, O2 goes down, let's reboot the server because it had some massive update, needed to restart. And we're going to fail over no problem. And 3, let's just power them off. We had a power failure. And load balancer does its thing. Just picks up the new server. So just like that, we've got a pretty robust web service here that deployed the website automatically and is up and running multiple servers in our Dallas metro. We could deploy them elsewhere if we wanted to, and we could still connect them through that load balancer. But that's all connecting through the Dallas metro at this point. So load balancers also create that point that you have to connect into. So it doesn't really do much for putting you near your customers, but does a lot for robustness. The load balancer primarily, its biggest benefit is we can access it through some of the cloud controller APIs so that we can create load balancers for Kubernetes and that sort of thing. So that's kind of the basics of getting servers and messing with networking. We saw some of the layer 2, getting those two servers to communicate with each other. If I wanted to put this all together and really get into doing it programmatically, what I'd start to do is diving into some actual infra code. In this case, Terraform. So this is a little example project I had set up probably about a year or so ago to just deploy. Did I get?
Yeah, you did log off there for a second. All right, I think you're back with the screen share.
Cool. Yep. I should be on wired networking. I'm not sure why that's happening. I'm sorry about that. But yeah, so Terraform, that's what we're talking about. So this is a Terraform project that actually goes through, we'll poke through the code for folks that aren't familiar with it here. I'm pulling in a slightly older version of our Equinix provider. Oh, that's a new feature. Sorry, I just got distracted by cool scrolly things I've never noticed before. It's going to actually pull in my API key, which I will remember not to show you. It's going to actually create a brand new project for us. So for instance, I'm in this Fen webinar project right now. We're going to create a whole brand new one for this test. We're going to pull in, it's actually going to request a special IP address that we want a global IP address to access. And then it's going to set up a number of computers wherever we've requested them here. So I want a couple in Silicon Valley, a couple in Singapore, a couple in Amsterdam, and a couple in New York. And then I'm actually going to figure out what that IP address was that I request. I'm going to output that back to me because we're going to set all of these up. We're going to configure BGP on all of these servers to route them all to the same IP address. So kind of like load balancing, but using networking protocols a little differently and routing protocols. And then we should be able to very similarly bring up these systems and access a very similar hello world type interface here. And you'll see all these are actually referencing a different module called compute. So if I dive into my modules, it's pulling in all of the variables that it creates originally, the same provider. It's going through, it's starting the BGP sessions and actually setting up the devices, and it's passing some other variables through to some setup scripts that I have, including, you'll recognize it, a cloud config that's running a bunch of setup commands. And this is pulling in a little Python Flask application that it's running in the background. That's not super important what it is. But it's pulling that in from another GitHub repo and deploying that on the servers. So let's go ahead and see what that looks like here. So this is the directory. We're going to do a Terraform init, just make sure that we've got the right files in place to actually deploy this. Best practice is to do Terraform plan. So this is going to show us the changes that will be applied after we commit or apply those changes. This is what it's actually going to do. And let's go ahead and apply it. So it's going through here. It's created a test project for us, and it's going through and bringing up that compute. So again, that test project, what did we name it? Anycast test Cobalt. Cool. Let's go into all things here. We've got that project that was just created, so it shows up already, and it's already got 8 servers deploying and provisioning right now. So we haven't had any failures at this point. It's pulling in all 8 servers. They're going to take a little while to deploy. So I'm going to let that sit for a minute. I'm going to keep an eye on it. I'm going to go back to my presentation real quick. I'm going to talk about a couple other use cases, and then we'll come back here and see how that deploy is doing. So let me hide my screen share, I think, and then I can I zoom? I can zoom. Demo time. Cool. So we've got a couple of use cases from some open source projects that I think really have good reasons to use our infrastructure and have like a really good story for it. So one is Alpine Linux. You're probably familiar if you've deployed a container of the Alpine builds that are really, containerized. They do their actual binary building for all architectures, right? 32 and 64-bit, x86 and ARM CPUs. They could do all that deploy through virtualization and everything else, or because we can spin up on demand, they light up bare metal, big iron to run their big complex build process. They do build, they do test, they develop the actual binary assets, and then they can deliver those all over the world using the Equinix network. So they're one of the ones that use that because virtual machines wouldn't be useful for them. And the fact that we're so adjacent to all of where everyone else is pulling these images makes it really beneficial for them to run the bare metal in our data centers. And finally, kernel.org. So again, if you've touched Linux, you've touched the Linux kernel. And I love this quote. I promise it's not us telling them to say it. But Robert Reeves has actually said Equinix is indispensable. Without it, half the internet breaks, because kernel.org actually leverages Equinix for their CDN. So again, the same concept of they've got big stuff. They need to move it around the internet very fast. And so the best place for them is to have it where it's adjacent to all of the clouds and on-prem and where everyone else is going to be pulling that down. Gives them both the control that they need and the power that they need in bare metal, as well as the convenience of that cloud location. So that's kind of the gist of what I think dedicated cloud fills in, and especially Equinix Metal happens to meet this role really well. Of we are inevitably working in hybrid and multi-cloud worlds. Even if you're fully in one cloud, say you're a startup project, but you're delivering something all over the place, right? So dedicated cloud providers like Equinix Metal that can sit at those crossroads and provide you both the sort of on-prem bare metal experience with the cloud type deployability and edge access is really what's keeping everything interconnected for us. Let me see how we're doing back here to really show off that example. How's screen one going to do for us now? Cool. We've got a couple still deploying. We've got a couple up and running. If we copy these here, because it's trying to do HTTPS. Don't do that. Why would you do that? I'm trying to jump ahead of it. We still got to wait for it to finish up before it's going to give me the IP address, and I'm trying to jump ahead of everything here. May not have finished configuring all our BGP. There we go. Cool. So it's actually pulled in the host name of one in Silicon Valley. So we've hit this IP address. We're using BGP to route this global IP to our server here. So 00SV is actually come up here, and that's the one that's closest to me right now. New York is still online. I'm in Vermont, and so New York will be closer once it comes up. But right now, Silicon Valley is responding first. Again, if you are somewhere else in the globe and you put in 147.75.40.84 into your browser bar, you should probably get the name of whatever server is actually physically closest to you, or I guess physically in network terms as well, right? Like it's technically the fastest to you over the network. So that's kind of a neat little trick that happens here. Leveraging BGP, the routing protocol, to set up a really robust network again that's both fail-safe. If I bring down this server 001 in SV, let's go ahead and reboot that one while we're at it. Or maybe I have to bring it down. Or it'll take, there we go. So we switched to 01. We can see that came online. The New York servers are starting up, so maybe it'll even switch again. Who knows? We can bring down all of Silicon Valley and see what happens there. So this can give you an even more robust architecture. As you see, it'll fail over to whichever servers are going to answer, even if they're not online. There we go. So now Singapore is where I happen to have connected to. Amsterdam, because that one's technically closer. Just Singapore responded first before. So that's kind of the art of possible here of running infracode. Is I set 8 servers up now with no interaction. I didn't touch them except for typing Terraform apply, and you can deploy a web app across the globe that's at the edge near all of your customers, and whoever can access it, if things go down, it stays up, and it's pretty neat. So I think with that. Actually, I should show destroying that too, because it's just as easy. Yeah, there it goes. If I was patient and waiting in Terraform, it would have just given me the IP address instead of me having to look it up. But knocking this down is just as easy. Terraform destroy. It's going to just make sure I really want to destroy everything. And it's going to go through. If I start refreshing this, servers are going to disappear until my project disappears. They're all going away, and then eventually this project will refresh and it'll fail. So I'm going to stop sharing here. And so thanks all for joining me on that journey through dedicated cloud and the Equinix Metal portal. If you want to know more, these are the places to find out more about Equinix, and also to check out the podcast that I sometimes host. But deployed.equinix.com, your site for all of these digital services. Equinix Metal, you can get info on Fabric and all the things and use cases and documentation. Getting started is in the top right corner. So deployed.equinix.com, get started, and you can get hands-on and build your own proof of concepts that you want to do. We've got the Equinix Developers YouTube channel. We do live streams there periodically. We're going to have a demo days that'll be hosted there as well. So check out more demos. Our one coming up in about a month will be around open source. So you can see more stuff that we do around open source. And yeah, the Traceroute podcast, I'm going to self-brag for a moment, got nominated for a Webby this year. So if you want to help me tip the vote entirely, you can go to bit.ly/TraceRouteWebby and vote for us. If you want to listen to an episode first, you can go to deploy.equinix.com/traceroute and you can listen to an episode first. I think the most recent ones that I'm on are some of the ones about AI. So, yeah.
Very cool. Yeah, and actually, why don't we leave that last slide up just so people can click on those during the Q&A. Yeah, so Finn, great presentation. Walt really liked, he said that was helpful, really enjoyed the explanation of hybrid bonded. So
Nice.
Thanks for that. So there are a couple of questions here. One of them, so love that table from Forest Brazil showing when cloud and data centers and hybrid cloud are appropriate. Do you see Equinix Metal as an alternative to cloud?
Yeah, it's a great question. So we're partners with most of the hyperscalers. So it's much less an alternative, and kind of what I've been pitching here. It can be looked at that way, but I think it misses the real benefit of a partner to those clouds. It's added in additionally to build that interconnection and really give you the world of control, like especially if you have data sovereignty issues or something else, but you've got like maybe a serverless app that processes your data, but your data has to live in a very specific location. We can handle all of that. You can have a lot of control over your data while still getting the benefits of cloud services that are on demand and run once and that sort of thing.
Okay. All right. Excellent. Let's see. Next question we have here. They're wondering, is there Terraform support for other Equinix services or just Metal?
Yeah, it is support for like the Fabric services as well are there. You can check out our Terraform provider, which I probably should have also provided a link for. But you can just type Equinix provider Terraform into the search bar, and it should be the first result on the Terraform registry. Let me see if I can copy and paste it into the questions box here. Can I do it? We're gonna do it. Cool. So that should give you the latest documentation for the Terraform provider for Equinix, including Network Edge, Fabric, and Metal services. So yeah, so you can integrate all of these through Terraform and have all your code documented in Git and all that lovely stuff.
Super. There's a question here from Chris who's wondering, isn't dedicated cloud the same as private virtual cloud?
So it is a little bit different because dedicated cloud is giving you much more of the access to lower level controls, right? Like the virtual private cloud is creating your own little private network space inside one of the hyperscalers. And our dedicated cloud in this instance is giving us more root level controls of our networking, of the systems themselves. You can break out the actual network ports on that server, put them both on layer 2, unbond them, have the actual system live in two different network spaces. Stuff you couldn't normally do in VPCs with virtual systems because you're beholden to the abstraction layers that virtual provides for you.
Okay. All right. Excellent. Let's see. Other questions. They're wondering, do you offer other services like storage or serverless functions?
Yeah, that's a great question. So yes and no. So something like storage is totally available. They often, because of the way storage is requisitioned and procured, it's a request that you make on your account. And there's a little bit more of a commitment to it than on demand. But it is totally available. So you can have storage services like NetApp or Pure Storage right alongside your Equinix Metal systems. And access and maintain those in exactly the same ways as everything else. But something like serverless functions, we don't do. We're providing you the baser platform again. So we're giving you the bare metal. If you want to build your own serverless function service on top of it, great. But we provide you the building blocks to do it. We don't give you the serverless functions already built out of the gate. But yeah, it's a great question.
Okay. All right. Excellent. Well, Fen, I think we've gone through most of the questions here.
Great.
You've already talked about how to get started with Equinix. Any sort of last thoughts for us before we wrap up?
I think that's it. I think my main thoughts and what I want to do is get people to think about cloud less as a competitive space and more as a cooperative space, right? Like in what ways can we leverage these different angles and interconnect them to build something better than just sticking in AWS or just sticking in on-prem, for instance? And what would that actually enable for you? And yeah, check out deploy.equinix.com and vote for us for our Webby so that we can get the People's Choice Award.
All right. Yeah. Well, congratulations on the nomination day. It's exciting.
Thanks.
All right.
Thanks
well, Fen, thanks so much for coming on. This was a great presentation, really informative. Really appreciate it.
Thank you. Thanks for having me. It was great.
All right. So we'll let Fen go, and we've got one more piece of business, and that is the Amazon gift card prize drawing. And so the winner of the $250 Amazon gift card today is Asmir Hodzik from Michigan. So congratulations to Asmir Hodzik. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Equinix for making this event possible. And thanks as always for attending and for your great questions. That's going to conclude today's event. Have a fantastic rest of your day.